Chapter 2 Chemical Reactions. What changes of substances are called physical phenomena? What changes are called chemical phenomena? What is a chemical reaction? When does it occur? How to recognize it? In a chemical reaction is the total mass of substances conserved. What does a chemical equation representing a chemical reaction tell us about the reaction? How to balance the number of atoms to write the chemical reaction? Lesson 12. The change of substances. In the previous chapter, you have learned about substances. This chapter will be about chemical reactions. Firstly, it is necessary to know which changes a substance can undergo. 1. Physical phenomena. Observation. Ice melts into liquid water. When heated, water changes into steam, water vapor, and vice versa. Dissolving grain table salt into water, we obtain a transparent solution. Salt particles cannot be seen, but it tastes salty. Heating the solution to evaporate all water, the range of table salt appears again. See figure 1.5, page 10. Remarked, in the above processes, both water and table salt still remain the same initial substances. These changes of substances belong to physical phenomena. 2. Chemical phenomena. Experiment 1. Mix an amount of sulfur powder with an equivalent amount of iron powder to obtain a mixture of two substances. Divide the mixture into two similar portions. A. Move a magnet next to one portion. Iron is attracted by the magnet. Figure 2.2. We know that iron still remains unchanged in the mixture and sulfur also. B. Put the second portion into a test tube. Heat strongly the bottom of the test tube for a while. Figure 2.3. Then stop heating. The mixture lightens and changes into the gray solid. This substance does not retain the properties of sulfur and iron. It is not attracted by the magnet as iron. It is iron 2 sulfide compound. Thus, when heated, sulfur reacts with iron, changing into a new substance. Experiment 2. Transfer sugar into two test tubes 1 and 2, figure 2.4. Hit the bottom of the test tube 2. White sugar changes into a black substance, which is cold, and there are droplets of water condensed on the wall of the test tube. Thus, when heated, sugar decomposes, changing into two substances, coal and water. Remarked, in the above processes, sulfur, iron, and sugar have changed into new substances. These changes of substances belong to chemical phenomena. 1. The phenomena in which a substance undergoes a change but still remains the same substance are called physical phenomena. 2. The phenomena in which a substance changes into new substances are called chemical phenomena. Exercises 1. What is the main signal to distinguish chemical phenomena from physical phenomena? 2. Which of the following phenomena are chemical phenomena? Which are physical phenomena? Explain. A. Sulfur burns in the air to form pungent gas, sulfur dioxide. B. Molten glasses blown up into round bottom flask. C. In the limestone kiln, calcium carbonate gradually changes into quicklime, calcium oxide, and carbon dioxide releasing outside. D. Alcohol in the open bottle evaporates. 3. When a candle made of paraffin is lit, it melts and penetrates into the wick. Then the liquid paraffin changes into vapor. Paraffin vapor burns in the air to form carbon dioxide and water vapor. Analyze and show that in which stages the physical phenomenon occurs, in which stages the chemical phenomenon occurs. Given that there is oxygen gas in air and the candle burns because this gas takes part in the reaction. Lesson 13. Chemical reactions. It is known that a substance can change into other substances. What is the process called? What changes? When does it occur? How to know it? 1. Definition. A change of a substance into other substances is called a chemical reaction. The starting substances that are changed in the reaction is called reactants, participants. The newly generated substances are called products. The chemical equation is written in words as the name of the reactants, the rules, the name of the products. For example, sulfur plus iron reduces iron to sulfide. It is read as sulfur reacts with iron to form iron to sulfide. Sugar reduces water plus coal. It is read as sugar decomposes to form water and coal. During the chemical reaction, the amount of reactants gradually decreases and that of products increases. 2. The progress of chemical reaction. As known in Lesson 6, a molecule is the representative particle of a substance and exhibits all chemical properties of the substance. This can be understood that when substances react together, it is the reaction between the molecules. It is said that the reaction between molecules shows the reaction between substances. For example, Figure 2.5. In the figure 2.5a, before the reaction, B, during the reaction, C, after the reaction. Based on the scheme in figure 2.5 indicate before the chemical reaction what atoms bond together, after the reaction what atoms bond together. During the chemical reaction, whether the number of H atoms and the number of O atoms remain the same or not, whether the molecules before and after the reaction are different from each other or not. Then we can draw the conclusion that in the chemical reaction, only the bonds between atoms change that makes a molecule change into other molecules. The result is that a substance changes into other substances. What are the substances in the above example? If a metallic element participates in a chemical reaction, after the reaction, this metallic element must bond with atoms of other elements. 3. When does a chemical reaction occur? 1. The reactants come into contact together. The larger the contact surfaces, the more easily the chemical reaction occurs. In the experiment 1b of Lesson 12, sulfur and iron are used in the powder form for this purpose. 2. It is necessary to heat to a certain temperature depending on a particular reaction. The heating can only be needed at the beginning of the reaction to initiate the reaction. For example, in the reaction between sulfur and iron, or sometimes it is necessary to heat continuously during the reaction. For example, in the decomposition reaction of sugar. However, there are chemical reactions that can occur without heating. For example, in the reaction between zinc and hydrochloric acid, only by pouring hydrochloric acid on zinc, it can be observed that there is a gas releasing figure 2.6. The chemical equation in words is zinc reacts with hydrochloric acid to form hydrogen and zinc chloride. 3. There are reactions that need the presence of a catalyst. It is the substance that promotes the chemical reaction to occur faster and remain unchanged after the reaction. For example, the reaction producing acetic acid. Vinegar is dilute acetic acid solution from soft white yeast as a catalyst. 4. How to identify that a chemical reaction is taking place? It is based on the appearance of new substances which have different properties from the reactants. For example, the iron 2 sulfide compound produced in the reaction between sulfur and iron does not have the properties of sulfur and iron anymore. And the other properties that can be recognized easily are the color. For example, white sugar decomposes to form black coal and water or state. For example, the forming of a gas as in the above reaction producing the precipitate. Besides, the release of heat and light can be a signal for the occurring chemical reaction. For example, a burning candle. See the exercise 3, lesson 12. 1. A chemical reaction is a change of a substance into other substances. 2. In chemical reactions, only the bonds between atoms change that makes a molecule change into other molecules. 3. The chemical reactions occur when the substances come into contact together. In some cases, heat or catalyst is needed. 4. The identification of chemical reaction which is happening is based on the signal of forming new substances. Exercises 1. A. What is a chemical reaction? B. What substances called the reactant participant? What substances is called a product? C. During the chemical reaction, the amount of which substance decreases, the amount of which substance increases. 2. A. What can we say? When the substances react together, the molecules react together, or atoms react together for metallic elements. B. What change occurs in the chemical reaction? What is the result? C. From figure 2.5 in the lesson, answer the questions. Does the number of atoms of each element remain the same after the reaction as before the reaction? 3. Write the chemical equation in words. If a reaction occurring when a candle burns. See exercise 3, lesson 12. Give the name of reactants and products in the reaction. 4. Write in the notebook the following sentences by choosing the suitable words from the box to fill in the blanks. Before burning, the paraffin is in the blank state. During the burning, it is in the blank state. Paraffin blank reacts with blank of oxygen gas. 5. Place an egg into a hydrochloric solution. The bubbles can be seen in the shell of the egg, figure on the right. It is known that hydrochloric acid has reacted with calcium carbonate in the egg shell to form calcium chloride water and release carbon dioxide gas. Show the signal to recognize that the chemical reaction is occurring. Write chemical equation in words. 6. When coal burns in the air, the chemical reaction between coal and oxygen occurs. A. Explain why is it necessary to grind coal before placing it in the stove. Then use a rod to light it and blow strongly until the fire catches coal. And B. Write the chemical equation in words, given that the product is a carbon dioxide gas. Further reading. In industry, essential substances for life and production or repair based on chemical reactions. For example, ammonia is produced from nitrogen and hydrogen gases in the suitable condition of high pressure, and iron as the catalyst. As the following reaction. Nitrogen gas reacts with hydrogen gas to form ammonia. Ammonia is the material for manufacturing fertilizers and other substances. In nature, there are reactions that are useful for humans. For example, in green leaves, there is chlorophyll that absorbs the sunlight energy and is the catalyst of the reaction. Carbon dioxide reacts with water to form glucose and oxygen. Glucose is just the intermediate compound and the final product is the starch. Thanks to this reaction, the air is fresh because harmful carbon dioxide decreases, while oxygen, which is necessary for the respiration, increases. Remember that plants contribute to the regulation of the weather in chapter Plants in Human Life in Biology 6. However, there are also harmful reactions which we need to prevent. For example, gas explosions in mines, forest fires, and the rusting of metals. Every day, the chemical reactions can be observed, for instance, in striking a match, burning the fuel, seeing food get stale, seeing the lamp water on the wall get dry, and seeing fireworks displays. Lesson 14, Practice 3. Signals of chemical phenomena and reactions. To distinguish physical phenomena and chemical phenomena, to recognize the signals of chemical reactions. 1. Conducting experiments. 1. Experiment 1. Dissolve and heat potassium permanganate purple disinfectant. Take an amount about 0.5 gram of potassium permanganate and divide it into 3 portions. Transfer a portion into the water in test tube 1. Shake it to dissolve the solid. Hold the test tube and strike it gently on the palm. Transfer 2 other portions into test tube 2 and heat. Move a glowing stick over the test tube opening. If the glowing stick reignites, signals show there is oxygen gas will be discussed in chapter 4. Then continue to heat. When it does not burn brightly, stop heating. Cool down the test tube. Then pour water into the test tube. Set it to dissolve the solid. Does the solid dissolve completely? Observe the color of solutions into test tubes. 2. Experiment 2. Reaction with calcium hydroxide. A. Use a glass tube to breathe to the test tube 1 containing water and test tube 2 containing fresh lump water. Calcium hydroxide solution. What can be observed in its test tube? B. Pour sodium carbonate solution into test tube 1 containing water and test tube 2 containing fresh lump water. What can be observed in its test tube? 2. Report. 1. Describe the observation. In which test tube does a physical phenomenon occur? In which test tube does chemical phenomenon occur? Explain. 2. Record the phenomena occurring in a test tube. What signal proves that there is chemical reaction occurring? Write the chemical equations of the reactions in words. Given that A. There is carbon dioxide gas in the breath. 2 new substances formed are calcium carbonate and water. B. One of the 2 newly formed substances is calcium carbonate and the other is sodium hydroxide. Lesson 15. The law of conservation of mass. In chemical reactions, is the total mass of substances conserved? This unit will answer this question. 1. Experiment. On scale lay figure 2.7, place 2 beakers 1 and 2 containing barium chloride solution, BaCl2, and sodium sulfate solution, Na2SO4. Place weights on scale B until 2 scales are balanced. Pour the solution in beaker 1 into beaker 2. Shake it to mix 2 solutions. The white solid is observed in the solution. It is barium sulfate BaSO4. The substance is water insoluble. A chemical reaction has occurred. That is reaction. Barium chloride reacts with sodium sulfate to form barium sulfate and sodium chloride. 2. The law. Before and after carrying out the experiment, the scale pointer remains in the same position. What can be deduced? When a chemical reaction occurs, the total mass of substances is unchanged. This is the basic content of the law. 2 scientists, Lomonosov, a Russian, 1711 to 1765, and Lavoisier, a French, 1743 to 1794. Independently conducted experiments with the precise measurements, then proposed the law of conservation of mass. The law is stated as follows. In a chemical reaction, the total mass of the products is equal to the total mass of the reactants. Explanation. It is known from lesson 13 that in chemical reactions there is a change of bonds between atoms. This change is only related to electrons. The number of atoms of each element still remains unchanged, and the mass of the atoms is constant. Therefore, the total mass of substances is conserved. 3. Applications. To apply, we write the content of the law into a formula. Assume that there is a reaction between A and B to form C and D. The mass formula is written as follows. Ma plus Mb equals Mc plus Md. where Ma, Mb, Mc, Md are the mass of substances. For example, the mass formula of the reaction in the above experiment is MbACl2 plus MNA2SO4 equals MbASO4 plus MnACl. In this formula, if the mass of three substances is known, the mass of the fourth substance can be calculated. Indeed, assume that A, B, C are the given mass of three substances. S is the unknown mass of the remaining substance. Here we solve the first order equation with one variable, such as A plus B equals C plus X, or A plus X equals B plus C. 1. The law. In the chemical reaction, total mass of the products is equal to the total mass of the reactants. 2. Application. In a reaction involving n substances including reactants and products, if the mass of n-1 substances is given, then the mass of the remaining substance can be calculated. Exercises 1. A. State the law of conservation of mass. B. Explain why in the chemical reaction the total mass of substances is conserved. 2. In the chemical reaction of the above experiment, the mass of sodium sulfate Na2SO4 is 14.2 grams. The mass of products barium sulfate BaSO4 and sodium chloride NaCl are 23.3 grams and 11.7 grams respectively. Calculate the mass of barium chloride BaCl2 involved in the reaction. 3. Burning completely 9 grams of magnesium Mg in the air gives 15 grams of magnesium oxide MgO. As known, burning magnesium is the reaction of magnesium with oxygen in the air. A. Write the mass formula of the occurring reaction. B. Calculate the mass of oxygen involved. Lesson 16. Chemical equation. According to the law of conservation of mass, the number of atoms of each element in the substances before and after the reaction is the same, that is equal to each other. Based on this and with the use of chemical formulae, we will construct chemical equations to express the chemical reactions. 1. Constructing chemical equations. 1. Chemical equations. The chemical equation in words of the reaction between hydrogen gas and oxygen gas to form water is as follows. Hydrogen gas plus oxygen gas equals water. Replacing names of substances with their chemical formulae, we obtain a skeleton equation. H2 plus O2 equals H2O. The number of O atoms on the left side is bigger. There must be 2 O atoms on the right side. Placing the coefficient of 2 in front of H2O, we have H2 plus O2 equals 2HO2, H2O. And now the number of H atoms in the right side is bigger. There must be 4 H in the left side. Placing the coefficient of 2 in front of H2, we have 2H2 plus O2 equals 2H2O. And now the number of atoms of each element on the two sides is equal to each other. The chemical equation of the reaction is written as follows. 2H2 plus O2 arrow 2H2O1. 2. Steps of writing chemical equations. Thus, the writing of chemical equations is performed in 3 steps. You will see more clearly through the following example. As known, aluminum reacts with oxygen gas to form aluminum oxide, Al2O3. Write the chemical equation of the reaction. Step 1. Write the skeleton equation. Al plus O2 arrow Al2O3. Step 2. Balance the number of atoms of each element. The number of both Al and O atoms on two sides is unequal, but oxygen element has more atoms on the right. We start with this element. First, make the number of O atoms on the right side even, that is, place coefficient of 2 in front of Al2O3, and we have Al plus O2 arrow to Al2O3. There must be 4 Al and 6 O, that is 3 O2 on the left. Coefficients of 4 and 3 are reasonable. Step 3. Write balanced chemical equation. 4 Al plus 3 O2 arrow 2 Al2O3 2. Note: do not write 6O in the chemical equations because oxygen gas exists in the molecular form O2. Namely, do not change the subscripts in the correct chemical formulae. Write coefficients in the same size as the chemical symbols. For example, do not write for small Al. If there are groups of atoms in chemical formulae such as OH group, SO4 group, they are considered as a unit to be balanced. The number of groups before and after the reaction must be equal. In some reactions in which there are groups of atoms that do not remain the same after the reaction, it is necessary to calculate the number of atoms of each element. For example, write chemical equation of the reaction carried out in Lesson 14, Practice 3, Experiment 2b. The chemical equation in words of the reaction is as follows. Sodium carbonate plus calcium hydroxide arrow calcium carbonate plus sodium hydroxide. Write the skeleton equation. Na2CO3 plus CaOH 2 times arrow CaCO3 plus NaOH. The number of both Na atoms and OH groups on the left is 2 and on the right is 1, and the numbers of Ca atoms and CO3 groups in both sides are balanced. Place only a number choose by yourself in front of the formula of one substance to write chemical equation. Na2CO3 plus CaOH 2 times arrow CaCO3 plus question mark NaOH 3. 2. The meaning of chemical equations. Chemical equations show the ratio of the number of atoms, the number of molecules among the substances in the reactions. This ratio is equal to the ratio of substances in the equations. For example, according to chemical equation 2, there is the ratio. The number of Al atoms to the number of O2 molecules to the number of Al2O3 molecules equals 4 to 3 to 2. It is understood that any 4 Al atoms will react with 3 O2 molecules to form 2 Al2O3 molecules. Usually, only the ratio of each pair of substances is concerned. For example, any 4 Al atoms react with 3 O2 molecules. Any 4 Al atoms react to form 2 Al2O3 molecules. Or any 2 Al atoms react to form 1 Al2O3 molecule. Try thinking of any ratio of other pairs. 1. Chemical equations express concisely chemical reactions. 2. 3 steps of constructing chemical equations. Write the skeleton equation including chemical formulae of the reactants and the products. Balance the number of atoms of each element. Find suitable coefficients to place in front of the formulae. Write chemical equations. 3. Chemical equations show the ratio of the number of atoms, the number of molecules among substances, as well as between each pair of substances in the reactions. Exercises. 1. A. What does a chemical equation express? What substances does it involve? B. What are the differences between the skeleton equation and its chemical equation? C. Give the meanings of the chemical equations. 2. The skeleton equations are given below. A. Na plus O2 arrow Na2O. B. P2O5 plus H2O arrow H3PO4. Construct the chemical equations and show the ratio of the number of atoms and molecules of substances in each reaction. 3. Do the same as in exercise 2 with the following skeleton equations. A. HCO arrow Hg plus O2. B. FeOH3 times arrow Fe2O3 plus H2O. 4. Given the following skeleton equation. Na2CO3 plus CaCl2 arrow CaCO3 plus NaCl. A. Write the chemical equation of the reaction. B. Show the molecular ratio of 4 pairs of substances in the reaction. Choose by yourself. 5. As known, magnesium Mg reacts with sulfuric acid H2SO4 to form hydrogen gas H2 and magnesium sulfate MgSO4. A. Write the chemical equation of the reaction. B. Show the ratio of the number of magnesium atoms with the number of 3 other substances in the reaction respectively. 6. As known, red phosphorus P reacts with oxygen gas to form P2O5 compound. A. Write the chemical equation of the reaction. B. Show the ratio of the number of P atoms with the number of 2 other substances in the reaction respectively. 7. Choose suitable coefficients and formulae to replace the question marks in the following chemical equations. Write in the notebook. A. Question mark Cu plus question mark arrow 2CuO. B. Zn plus question mark HCl arrow ZnCl2 plus H2. C. CaO plus question mark HNO3 arrow CaNO3 2 times plus question mark. Lesson 17. Review 3. To consolidate the knowledge of chemical phenomena, chemical reactions, the law of conservation of mass, and chemical equations, and fully grasp how to apply the law and write the chemical equations. 1. Key knowledge. 1. We confirm a chemical phenomenon when a substance changes into another substance. The change of substances called a chemical reaction. In chemical reactions, there is only the change of bonds between atoms, leading to the change of molecules and resulting in the change of substances. But the number of atoms of each element before and after the reaction still remains the same. Based on the law of conservation of mass, the mass of a substance can be calculated when the mass of other substances in the reaction is known. 2. A chemical equation includes chemical formulae of substances in the reaction with suitable coefficients so that the number of atoms of each element on both sides is equal. To construct the chemical equation, it is necessary to balance the number of atoms of each element and the number of groups of atoms, if any. For example, construct the chemical equation of the reaction in the following scheme. Al plus HCl arrow AlCl3 plus H2. First, balance the number of H atoms on both sides. Al plus 2 HCl arrow AlCl3 plus H2. Then balance the number of Cl atoms. The least common multiple of 2 and 3 is 6. Thus, Al plus 6 HCl arrow 2 AlCl3 plus H2. Subsequently, balance the number of Al and H atoms. Find the suitable coefficients for the chemical equation. Question mark. Al plus 6 HCl arrow 2 AlCl3 plus question mark H2. From the chemical equation, the ratio of number of atoms and molecules among substances in the reaction can be derived. This ratio is equal to the ratio of coefficients in front of the chemical formula of each substance. 2. Exercises. 1. The figure below is the symbolic skeleton reaction scheme between a nitrogen gas and hydrogen gas to form ammonia, NH3. Answer the following questions. A. What are the names of reactants and products of the reaction? B. How do the bonds between atoms change? Which molecules change? Which molecules are produced? C. What is the number of atoms of each element before and after the reaction? Does it still remain? Note. About the condition for the reaction to occur, see further reading of lesson 13, page 51, to identify a new substance, ammonia. Test one property of ammonia that is known in the experiment 1, lesson 7, practice 2, page 28. 2. The following statement contains two pieces of information. In the chemical reaction, only molecules change but atoms still remain the same. Therefore, the total mass of substances is conserved. Choose correct answer from the following answers. A. 1 is correct. 2 is incorrect. B. 1 is incorrect, 2 is correct. C. Both are correct, but 1 is not the correct explanation for 2. D. Both are correct, and 1 is the correct explanation for 2. E. Both are incorrect. Write in the notebook. 3. Calcium carbonate CaCO3 is the main component of limestone. When limestone is heated, the following chemical reaction occurs. Calcium carbonate arrow, calcium oxide plus carbon dioxide. Given that heating 280 kilograms of limestone gives 140 kilograms of calcium oxide CaO quicklime and 110 kilograms of carbon dioxide CO2. Write mass formula of substances in the reaction. B. Calculate the weight percentage of calcium carbonate in the limestone. 4. Given that when ethylene gas C2H4 burns, the reaction of this gas with oxygen gas O2 occurs to generate carbon dioxide CO2 and water. Ethylene is an organic compound. The valence of carbon in this compound will be mentioned in Chapter 4, Grade 9, Chemistry. Construct the chemical equation of the reaction. B. Give the ratio of the number of ethylene molecules to the number of oxygen molecules and carbon dioxide molecules respectively. 5. Given the following skeleton equation, Al plus Cu SO4 arrow Alx SO4 y times plus Cu. Determine the subscripts X and Y. B. Construct the chemical equation. Give the ratio of number of atoms of the metallic element pair and the ratio of number of molecules of the compound pair.